Good afternoon, everyone, and thank you so much for joining us online for our first Gala of Giving. While I would very much prefer to be talking to you face to face, I am absolutely delighted to have the opportunity to connect with each of you virtually and to offer my thanks for your support through this extremely challenging period. Needless to say, COVID-19 has had a major impact on the Institute this year. In many ways, to borrow from the opening line from Dickens's Tale of Two Cities, this year has been the best of times and the worst of times. When the pandemic hit, almost overnight, all our fundraising events were cancelled. From a financial standpoint, we were in turmoil. Team members found themselves in disparate locations. A limited number of research staff were rostered into the labs to keep essential research going, and we had no idea of what lay ahead of us as we went into lockdown. The enormity of the challenge and the sense of responsibility to see the Institute through this difficult time has at times seemed overwhelming. But I have to say, though, that this situation has brought out the very best in our Institute. Everyone who is associated with this organisation has reason to feel exceptionally proud of what has been achieved this year, because despite all the obstacles along the way, our progress has actually been extraordinary. The Zero Childhood Cancer Program, which we run in partnership with the Kids Cancer Centre at Sydney Children's Hospital, continues to shine brightly. Results from the first 250 children enrolled on Zero's national clinical trial were published earlier this month in one of the world's leading international medical journals, Nature Medicine, and those results are so exciting. In 90% of children, the Zero team was able to identify the specific genetic change driving their cancer. And in 70% of children, a personalised treatment plan was able to be provided. Best of all, 70% of children who received their recommended treatment had a complete or partial response, or their disease was stabilised. Given that these are children who had exhausted all other treatment options, these results are frankly outstanding and have exceeded all our expectations. We've also made extraordinary progress with our other research programs. In January, we published 2 papers outlining our contribution to the development of a new drug that appears very hopeful for the treatment of infant leukemia, an aggressive blood cancer that affects babies. And that drug is now already in clinical trials for adults as a precursor to pediatric trials. Planning is also underway for an international clinical trial for children with neuroblastoma, based on our research demonstrating the promise of a new treatment approach called polyamine inhibition therapy. Our brain tumour team has also shown that this same therapy appears to be extremely effective against a deadly brain cancer called DIPG, a terrible terminal brain cancer that you'll hear more about in our videos soon. All of this and much more has been taking place as we've worked remotely in a climate of enormous uncertainty. Tonight, it's all about bringing our research to life for you. And I am so proud to be introducing some of our new young emerging team leaders. You are going to be hearing from some of our A-team, Doctors Charlie DeBock, Josh McCarroll, and Far Valdesmora. Each of them are outstanding young scientists who represent the next generation of research leaders who have been handpicked from a competitive international field to build their own research teams at the Institute, only to find themselves working remotely and without any of the usual structures that support young research leaders at this stage of their career. Despite this, they have continued to drive their research forward, and we are so proud of everything that they have achieved. Tonight, they will explain their work to you and their passion, not as scientists, but simply as people. And that is because it is people who will cure kids of cancer, leveraging the latest technologies and working together. It is people, our researchers, our partners, and every one of you here tonight with us online who will change the future for children with cancer. Your support has allowed us to keep going when we truly wondered if we actually could. It is because of this support that I absolutely believe that young researchers like the three that you're going to hear from shortly, coupled with people like you, will mean that one day we will cure all children of cancer, and that it is not if, but it's when.
Yeah, so my name is Charles de Bock and I'm one of the new team leaders at the Children's Cancer Institute. And I'd like to share my story about my two great friends, Mark and Laura. I've known Mark and Laura for over a decade now, and they are the proud parents of two amazing kids, Karis and Cole. And it's Karis who I want to tell you a little bit more about, because she loves ice cream, she loves swimming, she's a great swimmer, and she loves climbing trees with her brother Cole. But on April the 15th this year, I received a call from Mark. And I remember that call because I was about to sit down with my own family for dinner. And Mark told me that Karis had just been diagnosed with leukemia. I mean, this is the research that I've dedicated the past decade of my life to finding better treatments. And so whilst many of us in April were probably wondering where we're going to get another toilet paper roll or a packet of pasta, Mark and Laura were about to contend with undergoing intensive chemotherapy with Karis at the Sydney Children's Hospital. And chemotherapy is what she received. She received an entire battery of different drugs with names such as methotrexate, vincristine, 6-mercaptopurine, dexamethasone, cyclophosphamide, alisparaginase, and the list goes on, all aimed at killing every single leukemia cell in Karis's body, in her blood, and in her bone marrow. But these drugs are pretty blunt instruments and are designed to kill all rapidly dividing cells. So Karis loses her hair, and she loses her entire immune system because all her normal blood cells are also killed as part of the chemotherapy. And as a result of that, Karis finds it very difficult to fight simple infections. And so she's at risk of not being able to get an infection, or she will be at risk of an infection if she gets a simple scratch. And so she's always going back to hospital with a temperature. And not only is she then having to take heavy courses of antibiotics and antifungals, but she's often on anti-nausea tablets, and on the really, really bad days, morphine to cope with the pain and discomfort. And so the only way I can describe this full frontal assault on Karis, who's only 7, is the same as you taking a flamethrower to weed your garden. Yes, highly effective, there is no doubt, but the collateral damage to all the healthy cells of Karis's body leaves a long shadow for the rest of her life. This is not to mention the stress on the relationship between my friends Mark and Laura, and Cole, Karis's little brother, who often asks questions about where her sister is when she has to stay overnight because she's fighting another infection or undergoing more chemotherapy. But what happens if I could tell you that instead of wiping out her immune system, we could actually harness the power of that immune system to fight the leukemia? Now, this isn't some sort of science fiction. This is the basis of what we call an immunotherapy. And one type of that immunotherapy is called CAR T-cell therapy. This is where we take the T-cell from the patient and we re-engineer that cell to go and fight that leukemia cell like nature's own stealth bomber, killing each cell one by one. But the challenge has been trying to find something which is unique about the leukemia cells, which is not on the surface of normal blood cells. And I can tell you that after 12 years of research, we've been able to identify one of those targets. Not only that, but we've been able to successfully raise antibodies to that target, which is the foundation for that immunotherapy. Moreover, we've been able to take that antibody and sequence how it recognizes that and generate the first CAR constructs, which we hope will be very unique and selective for leukemia cells and preserve your own human blood cells. And that is, just last month in October, we received the first 4 tubes of those CAR constructs ready for us to test in the lab. And this is why I'm here today. I'm here to ask for your support to build on this momentum, because you're probably wondering, if I give $5 or $10, what will that actually mean? Well, $500 will mean that I can grow the cells for another month in the lab. $10,000 means I can sequence another series of those antibodies, so we get another chance of building more CAR constructs to test in our model systems. And in fact, $20,000 or more will allow us to move our CAR T therapies into testing them on real patient leukemia cells using our avatar models. I have cycled with Jackson, the father of Amity, and it's in part of the Endure for a Cure. I've jumped out of a plane with Darren and Sarah Batchelor, the parents of Isla, who also had leukemia, all in aid of raising funds and awareness of children with cancer. Because, I will keep going if you will. There's nothing I would like to see more than Karis and kids after Karis back in that tree, climbing and having fun with their family. Thank you.
Hi, I'm Josh, and I've had the privilege of working at the Children's Cancer Institute for 13 years. So I'd like to tell you a story about a 12-year-old boy I know very well. He was active and he loved playing sport, and he dreamed of playing soccer or cricket for Australia one day. And then out of nowhere, he collapsed while he was playing soccer. And the next day, he found himself lying in the oncology ward. And he looked at all these kids with no hair and he thought to himself, what on earth could be wrong with them? Little did he know he was going to be one of those kids. Now, I'm happy to say that after multiple surgeries, radiation and 2 years of chemotherapy, he was cured. But cancer did leave its mark on his life in the form of treatment toxicity, which has damaged the normal cells, and it's affected his heart and lungs. And he's also had operations to remove his thyroid due to radiation toxicity. So it's been my mission to develop drugs which are effective at killing the tumour cells and less toxic to those normal healthy cells in the body. Now, many of you would be aware that the survival rates for childhood cancer are improving and can be up to 80%. But sadly, there are still kids that do not respond to treatment, and their chances of survival are poor. As I just mentioned, a big problem for kids is having treatment toxicity, which causes damage to all their healthy cells in the body, and this limits their quality of life. Children diagnosed with brain cancer, they face a tough road, not only in terms of survival, but from suffering from this treatment toxicity, which can affect their learning, their memory, and their speech. And so why is this? Well, the brain has a natural protective barrier that's designed to keep toxic drugs or molecules away from the brain. And the barrier works very well, it does a good job at this. But the problem is, it's really hard to get chemotherapy drugs to the brain tumour cells. So as a consequence, we need to deliver higher concentrations of chemotherapy, hoping that we can get some of that drug to the brain tumour. But the problem is chemotherapy isn't specific to just tumour cells. So it'll affect the liver, the kidneys, the heart and the lung, and cause damage to these cells. And this is a real problem for kids because many of those normal cells are still growing. So we want to change this. Could you imagine a future where we treat kids not only with the intent to cure their disease, but to do it in a way where we minimise or even eliminate the toxic side effects so they can live a long and healthy life? So what's the solution? We believe it's with tiny nanoparticles to be used as delivery vehicles for chemotherapy drugs. And we can make these nanoparticles in the lab. Now, these nanoparticles are 5,000 times smaller than the width of a single strand of human hair. Importantly, we can package chemotherapy drugs into these nanoparticles. Then we can actually decorate the surface of these nanoparticles with proteins that are designed to recognize that barrier in the brain and squeeze a nanoparticle through it. And once the nanoparticles are in the brain, they can selectively bind to the tumour cells. So what's the benefit of this? The benefit's twofold. One, we'll get more chemotherapy drugs to the brain tumour cells so we can kill them, but importantly, we can minimise its interaction with those normal healthy cells so that we can reduce those toxic side effects for the kids. So one more thing I'd like to share with you. This research is very important to me because that 12-year-old boy I spoke about, that was me. So I ask you for your help. Please support this course so that we can accelerate our research, optimize these nanoparticles in the lab, and get them to the kids as quickly as possible. Thank you very much for your time.
Good evening, everyone, and good morning to my family in Spain too. So, most of you probably know who Neil Armstrong was. Yes, the first man to land on the moon. But what you probably don't know is that Neil Armstrong had a daughter who passed away at 2.5 years of age in 1962 from a rare type of brain cancer called DIPG. This is the same cancer type that took Liliana's and Amethyst's lives, as you have seen in the video. Many people say that the death of Karen, Neil Armstrong's daughter, or Muffy as he used to call her, was the main driving force of why her father became the first man to step foot on the moon in 1969, 7 years after Muffy's death. Some even say that he hoped to find her there. Every parent's worst nightmare is to be told that your child has cancer. And even worse, that he or she only has 300 days to live. Yes, only 300 days. That's not even a year. One more birthday or one more Christmas if you're lucky. As a mom of 2 young children, I can only imagine what this must be like. The thought of only having 300 days left with my child, with 0 chance of survival, is just too hard to imagine. So this is the reason why I decided to shift my research towards finding a cure for the deadliest childhood cancers. So it is my mission now in life to find a cure for untreatable cancers like DIPG. DIPG is a deadly type of brain cancer that occurs in children. It has 0 survival, and these kids have only 300 days to live since diagnosis. And the worst thing is that there has not been any effective improvement on the treatment of DIPG for the last 40 years. So pretty much no change in diagnosis since Muffy's death back in 1962. But things can change. We can change the future. In 2012, thanks to medical research, there was a major breakthrough on the understanding of DIPG. Scientists discovered that the main cause of this disease is a mutation called H3K27M. This is a mutation in a protein that causes a ripple effect. One single change in a single letter of the DNA makes a deadly tumor. These ripple effect proteins are called epigenetic factors. I have been studying these ripple effect proteins for the last 10 years in the context of adult cancer. And thanks to the 2012 discoveries, now I can apply this knowledge to the IPG. In fact, we have drugs that are able to stop the ripple effect features of these proteins. And now we want to use these drugs to stop the ripple effect of the IPG. Now we can see the light at the end of the tunnel. Knowledge is power. And now we have the knowledge, we have the expertise, the technology, the people, the resources to win this war. But we still need you. We need your support. We need your donation to help us make the dream of a cure come true. Even the slightest improvement on the survival of these kids will change their lives. Imagine they could celebrate another birthday, or many more birthdays, another Christmas, or many more Christmas. So I would like you to finally remind you of Neil Armstrong's famous words. That's one step for man, one giant leap for mankind. Make a donation today, and you can change children's lives forever. So I would like to leave you with one last thought. If Neil Armstrong had the choice of saving his daughter's life or going to the moon, which do you think he would have chosen? Thank you.